everyone, welcome to our last day of Global Hack Week. Today we are featuring, this week we are featuring Data Week, and for the first time ever, I'll be making a stream about neural signals, which is not quite related to regular things that you can see on your day-to-day life as a computer science developer. So basically, I wanted to make these series of streams because you all been asking for me to make more streams related to robotics, hardware, and electronics. So I said, why not take the opportunity to use Data Week, especially because neural signals has a lot to do with data processing and data handling. So hopefully we'll be covering all of that today, and we'll also get some hands-on experience on how this is used. So for this first stream, I'm going to try to keep things short because then we'll be having a second stream afterwards this. So it will be a total of 4 hours. I'm not gonna take the whole 4 hours just talking and explaining things. We'll also have chances to make our own project and test this and see some live demos so you get a bit more entertained. But yeah, basically during this first stream, we'll mostly cover explanations and how to understand everything. So hopefully for the second stream, you'll be able to get some hands-on experience of these tools. And I also brought some hardware with me so I can show you during the live stream how it looks like and how it actually looks live or when someone's wearing it. And then you'll also get to test your own neural signals using some online demo that we'll be creating by ourselves using special hardware. But yeah, don't forget to check in. I already sent out a link on the chat. I know we're almost done with Global Hack Week. This is basically our last day. We'll be having closing ceremony tomorrow at morning. So hopefully you get to wrap up your projects and learn a lot from Data Hack Week. So I always usually stream at the beginning of the week, but this was the days that basically work with my schedule so I can be here with you all. But yeah, let's get started. Oh, hi, very nice to see you here. And I always love to see bee emojis. Okay, so I believe I haven't introduced myself. My name is Jocelyn. I'm a coach here at Major League Hacking. I'm also on the fellowship team, and I like to stream as well during Global Hack Weeks. You've probably seen my streams as well. Some of my fun facts is that I like salsa dancing and I collect Minecraft bee plushies. But recently, I think I've been starting collecting a bit more because now with all of the Minecraft movie coming out, I think there was a lot of merch that was out there. So hopefully I took that as an opportunity. Something that I always mention is that I'm into robotics and neurotech, and hopefully today I'll be teaching you something about neurotech as well, so you can also be experts after this stream. But yeah, there's my GitHub and my Instagram in case you want to follow me. I just recently made my account public, so I'll be hopefully posting content really soon and see how that goes. That's another path that I haven't explored yet, so I'm just starting onto that. Great. If you have any questions during this stream, always feel free to reach out and always feel free to reach out. I'll be on the chat. We always like to have some lovely side conversations about random things. So it's always nice to hear how our hackers doing. So for today's agenda, it's really packed. We have 2 streams coming up, but for this first stream, which is part 1, we'll be getting started with EEG signals. So basically understand what they are and how they are used. And we'll be seeing some examples of common headsets or some of the common hardware that's used on these areas. Then we have an introduction about BCI, so basically brain-computer interfaces. We'll see some examples of common projects that you can build by yourselves, and I'll also be showing some of my own projects that I built using these types of technology, so hopefully you can be inspired and you can follow the steps as well. And finally, we'll be downloading some important software that we will be using during these 2 sessions, which honestly, this software is not very commonly known, but it's definitely known by the BCI industry and people that are into analyzing these types of patterns. So now you'll be able to get to know it as well. My goal after this session is that you will understand neural signals, which are EEGs, and BCIs, brain computer interfaces, to start your first project. So let's keep in mind that these topics are not easy to handle. So this is not something that you can easily learn out of a YouTube video. These are actual technical topics that require perhaps weeks or months of preparation to understand them as well. And as I always like to make my streams very beginner friendly, I'll be talking about all of the basics to get you started. So you, once you go ahead and search it online or watch a video or whatever form of learning that you want to follow, you will be able to understand most of the concepts that you are seeing on the screen. Okay, so to get started, we'll be seeing some EEG signals intro. So what are EEG signals? So basically, these are called electroencephalographic signals. It sounds like a riddle to say the whole name. That's why we like to put that into short words, well, a single word, which is EEG signals, and they're basically used to evaluate the electrical activity of the brain. So you basically are measuring your electrical activity that's happening on your brain. So we exactly don't know what's going on in there. We just know that we want to measure them so we can then further analyze them. And this evaluation is in the form of signals. So if you've taken courses that are related to signal analysis, everything that's related to sound perhaps and frequencies, so if you've seen what a signal looks like, if you want to measure it through an oscilloscope or whatever tool that you're using to measure signals, well, EEG signals can also be measured and can also be graphs, and you can also see them directly. Here is just a picture of an example of what they look like. Actually, these signals look really, really clean. You will then be seeing some examples of signals that are not very clean, and we will be learning how to clean them and filter out the noise that's going on during the signals. So I basically mentioned that they are there to measure your electrical activity, but that doesn't really say much about what's going on. So usually, if you want to describe EEG signals to someone, you can just say like, "Oh, they measure electrical activity that's going on your brain. It's neural activity." But if you want to get a more in-depth explanation about what do they actually measure, so here's a direct explanation. There are basically these tiny voltage fluctuations that happen on inside your brain, and those happen exactly when the neurons communicate with each other. So we've all learned during our biology classes during primary school or probably junior high school about neurons and what happens when they interact with each other, and that they're basically on your brain, and it's what happens during brain activity. So EEG signals actually measure these voltage fluctuations that happen when the neurons communicate with each other. So if you only have one neuron, it's just like existing there. But then if two neurons communicate with each other, they produce voltage fluctuations. And that's why we're seeing in here positives and negatives, because it's basically related to electricity. So what you're seeing on the graphs in here, those are all electrical impulses or action potentials, which is actually the word that's related, the concept that's related more to neurons. And these voltage differences, they are measured, of course, in volts or microvolts, because they're very, very small. So they're very tiny. I mean, imagine having a reaction that's 1 volt. So that will be too much to handle in your brain. So these are very small measurements of volts that are happening in different scalp sites. So you can have electrical impulses all over your head on your scalp that are going on due to the interaction and communication of your neurons inside your brain. So this is actually going really, really into depth about how the EEG signals are measured and what they actually represent. So you wouldn't explain this to someone on a day-to-day basis. It's just for you to say like, oh, how cool. I'm actually measuring my neuron interaction inside my brain. So hopefully when you see those weird graphs plotting on your software or whatever thing you're building online, you will now know what they actually represent in your brain, and that this is just basically measured in a voltage to time scale. Okay, and this is just a nice representation of the neurons on your brain. And now we have another important concept in here. So, how are these things actually measured? So, we all know that sensors are basically in there to measure stuff. So, in this case, we use sensors as well called electrodes in order to measure our brain waves. So, these electrodes are placed directly on our scalp to detect these tiny voltage differences caused by neural activity in the brain. And depending on the place that you place them, it's what they're going to mean or what you will be analyzing on your graphs or whatever implementation that you want to do. So there's different placements. If you know a bit about medicine or you study biomedical engineering or something related with the brain, like neurotechnology, or basically things that are related to human anatomy, you'll be knowing that there's different locations on your brain. So you have different lobes, and each lobe represents a specific thing that you can do. So creativity, mobility, your eye movement, your hand movement, a lot of things. And to classify them, we use these notations in here, such as your frontal lobe, parietal lobe, occipital lobe, and temporal lobe. And they all mean different things. We'll be getting into that in a bit. But you basically need to know that sensors or electrodes are placed in specific sections from your brain to measure a specific characteristics from the brain signals that you want to acquire. So this actually makes a lot of sense because imagine you just putting sensors on your scalp, not knowing which positions they're taking. So it actually doesn't work like that because if, for example, I place a sensor over here, it will be different as if I place a sensor like on my backside or on my upper side. So it will be different because your brain is divided into different sections, and you will be measuring different things depending on the position that you are placing your sensors. So from these concepts, you basically just want to know that sensors in EEG signals are called electrodes, and you can place them in different positions from your scalp. And for this, we use a measurement system called 1020 system. So this is actually a really popular system. I think it's been around for since I don't remember the exact date, but it's been around for quite long. And it's just basically for scientists and people that want to get into EEG signals to know where exactly to place electrodes. So we know that there's different sections on our brain, and we know how to identify them. And perhaps we can have an idea of where they are, all of the locations are on our brain, like physically, just by seeing from a picture. But by using this 1020 system, we actually are making sure that the electrodes are being placed on the correct position. So usually commercial headsets or headsets that are used to measure these types of signals, they already have the positions on the headset that you are wearing. So for example, on this image, we have this person over here wearing this headset, and that headset has 32 channels, and those channels, they already have the positions where the sensors are going to be placed all over your scalp. So depending on the activity that you want to measure, it's the electrodes that you're going to use, because you're not going to be using a headset that has like 48 channels or 32 channels if you don't need all of the 32 channels. So there's headsets that handle 4 channels or even 2 channels, depending on the application that you want to build. And I'll be explaining the relationship between channels and application that you want to build, depending on the things that you want to do. So in this picture, we're seeing the colors represent each of the lobes that we have in here. So if we go back, we have, for example, the parietal lobe, which is yellow. And then if we go to this screen, we are seeing the yellow electrodes over here that had I think it's a P, because P means parietal. So that's basically what the notation means. And then if we see F from frontal, Then we go over here, and all the blue electrodes have an F at the beginning, which is basically frontal from F. We have a question over here. Those electrode placement has something to do with Brodmann areas. I don't know what Brodmann areas are. My apologies. If you wouldn't mind explaining the concept, I might be able to answer that. But I'm pretty sure they do. But just to be clear, if you provide an explanation, then maybe I can recall something from that. Okay, so from this explanation, just know that there's this system called 1020, which basically knows how to locate each electrode on the scalp, so you know which specific things to measure. Then there are different types of sensors or electrodes out there that you can use. So you can either classify them by different categories. So you can classify them by either being wet or dry electrodes, or also by material. Because depending on the material that you have is the conductivity that you're going to have for your electrical signals. So if we remember electricity concepts, we all know that different types of metals, they conduct electricity differently or on a different way. So by having different materials is the conductivity and the quality that you're going to be having. Of course, some materials are more expensive than others, and some are better than others as well. In my I always like to use wet electrodes when the headset allows it, because wet electrodes, they use a specific saline solution that you wear on your scalp, and that basically allows for the conductivity to be better. It definitely looks weird and it feels a bit sticky on your head, and it's very yucky for your hair, but it's a really good way for measuring encephalographic signals. And then we have dry electrodes, which are just basically these things that you put in the scalp of your head, and they are good, but you need to be really good on where to place them and make sure that they are acquiring the signals correctly. Because otherwise, you'll just be measuring noise, and your signal quality won't be that good. So usually commercial headsets, they have their own softwares that allow you to know if the signal is being read nicely. But if you're using like your own headset, or you're using a headset that doesn't have like any support of an SDK or like their own software, then you'll be needing to analyze those signals by yourself and determine if the electrodes are being placed correctly. So this is just a classification of electrodes that you can use. Usually when you buy your headset, you don't need to worry about which electrodes to use, because the headset has its own electrodes. This is only for you to know that there's different types and what's the difference between them, because you'll be hearing this word electrode a lot. Not only in EEG signals, they're also used for EMG signals, or the ones that measure muscular activity on your hands. So yep, they're basically a bit different. Okay, so we've seen quite a few concepts which are really interesting, and that's mostly all like a really nice summary of EEG signals. So three important things. EEG signals measure voltage fluctuations, which we already know that they're measured in volts. We can see in here on our scale that we have volts, and then we have time. So that's basically your graphs. You have volts, and then you have times on the x-axis. We measure those signals using electrodes, which are the things that this person is wearing over here, the electrodes, and he's using an EEG cap, or basically a headset that you can wear. You put it on, and then you have all of the electrodes using the 1020 system. We now know that there's different types of electrodes, and we place them using the 1020 system. So yeah, so those are three important things to know from this. I guess just by knowing this, you should be good to go for everything related to EEG signals. Of course, there's more things to learn, and we'll be getting into them when the time comes. Right now, it's just important for you to know that, so we can move on and explain what BCIs are, and also some of the most common headsets that you can use. So you can also see some examples, and you can make these things a bit easier to understand. Okay, so now getting into EEG analysis. So basically now we learned what EEG signals are, how can you measure them, how can you display them, how are the sensors placed in order to measure them. But measuring them is just one part of the challenge. Then the second part of the challenge is actually analyzing them and knowing what they actually mean. Because there's a lot of things that you can do with those signals, and we'll be getting into some of the things today, but I will definitely not cover everything because it's quite a lot, and there's even some things that I don't understand yet. And I'm also a student, and I don't even study biomedical engineering, but I would say I'm a nerd for this topic. So I basically like to research on my free time. But hey, there's things that we don't know yet and that we will continue learning. So that's what the whole learning path is for. And that's why we love to make these Global Hack Weeks available for everyone as well. Okay, so EEG analysis. So there's this first thing called brainwaves. So brainwaves are EEG signals. You can call them whatever you want. Um, yeah, EEG signals are basically described in terms of brainwaves because they are waves coming from your brain. I guess it's easier for people to relate a bit more when you call them brainwaves instead of calling them encephalographic signals, which sounds super weird. These brainwaves or EEG signals, they are rhythmic oscillations at different frequencies. So if you've heard about radio frequencies or obtaining the frequency from a graph, that's related to brainwaves because you are basically seeing oscillations. So basically like the graph that you're seeing at different frequencies. These frequencies, they actually mean different things. So they actually reflect different mental states, the level of sleep that you are in, or different brain functions. And here's a nice graph about how the electrodes are being placed, and then having your brain in there, and then finally having your EEG reading. So from these, I just want you to know that these signals, they measure oscillations at different frequencies. And these frequencies, they mean different things. So let's get into it. So now we're hopefully be getting into more complex ideas. So frequency classification, there's different classifications that you can have depending on the frequencies that you're getting. So for example, if you have your brainwave and you filter that brainwave to be between 0.5 and 4 hertz, then that means that your frequency is on a sleeping state. So if you put on your headset and you're getting this type of signal, which is from 0.5 to 4 hertz, that basically means that you are into deep sleep and you're dreaming. So I don't know if you've heard about those studies that go on about sleeping patterns and everything related to deep sleep and what you're dreaming. So usually, what researchers do is that they focus on these frequency, which is from 0.5 to 4 hertz. And then the most common ones are awake and resting, which is these two, beta and alpha. Those are the most common ones. They relate to mental activity, physical activity as well. Also, when you're kind of like in a resting state and you're just concentrating or existing. So if you want to analyze things related to how you're moving or how you are processing, for example, math problems or concentrating or being on a relaxed state, you'll be wanting to focus on beta and alpha signals. So I know this might sound like a lot, but you just want to know that EEG signals are classified into different frequency bands. And depending on the frequency band that you select, it is going to be related to different brain states. So for example, no. I'll give that example later on because then I believe I'm going to confuse you a bit more. But yeah, I guess this graph is really clear. It has emojis and everything, depending if you're like sleeping or if you're awake and you're in your complete concentration stage. Uh, but yeah, everything is related to frequencies, and you'll see why on our example coming up. I think I have another diagram in here. So depending on which frequency you are, is the brain state that you're going to be having. So if, for example, you are a scientist or a researcher and you want to analyze your subconscious state when you're sleeping. So you'll be wanting to focus on delta signals. And if you can see from each of this, there's more activity, right? So when you're in deep sleep, your brain activity is like, ooh, just like a wobbly line, like a nice round hill. But when you are multiprocessing, you're doing like many things, you are perhaps running or you are making like a super hard math problem and you are stressed and you have many things going on. So a lot of brain activity going on through your thoughts, then you'll be having like super intense brain signals going on. They're going to be like on and off, and they will be from 30 hertz and above. So the more that you go on this graph, I would say signals just they are more intense, right? So for brain computer interfaces or the signals that we're going to be focusing on today, we're mostly going to be focusing on alpha and beta brain waves. Why? Because alpha waves, they basically relate to creativity and when you're focused on something, and beta waves, they are also for concentration and how alert you are from your external environment. And they also have to do a lot when you are thinking about moving your hands or like opening and closing your hands or whatever thing that's related that's going on with your body as well. Yeah, you don't need to worry about learning them all. Honestly, sometimes I even confuse them and I forget about them. I know they exist, but sometimes I just forget what they mean. I just know that alpha and beta are kind of the most important ones if you are dealing with BCI stuff. So we'll be focusing on those two today. You don't even need to learn like the frequency bands that they are located at. You can always search them online. Honestly, I remember having these meetings with my research professor, and I remember that every time we met, she would ask me like, "Oh, do you know where the alpha frequencies are?" And she expected me to say a number, but I just couldn't remember because it's hard. It's like memorizing something. But hopefully, with practice, you will be learning those frequencies, and you won't be needing to memorize them or look them up online every time that you want to use them. Okay. Awesome. So I guess we covered some of the, I'll say boring stuff because it's kind of a lot. There's a lot of content in there. So now let's get into some fun hardware that's used. And hopefully you can see if your university or if your research lab or organization has some of these headsets so you can go ahead and use them. Personally, I don't own one because they're very expensive. I usually borrow them from labs at my university because they're hard to get and mostly because they're very expensive. And that's why I feel that these types of technologies are still not consumer friendly because they tend to be very elevated on their prices. So the first one, which is the most accessible one, I think this one is around 200 USD. I think this is a very common one. I would say it's the most commercial one, and it looks really nice. It's just like a headset. You wear it like below your ears, and then you have like this band on behind. And this has four electrodes. You have two that are like right behind your ears, and then you have others that are like going into your back or your front. So they basically put it like a weird band in here. It looks kind of weird. I wear this myself, I believe, a year ago. It's not very uncomfortable, but then your ears start getting tired, and it's kind of comfortable at some point. But yeah, this one has four electrodes, and we can see them in here on the 1020 position. You have some behind your ears, and then you have other two on your frontal lobe. That's why the F in there. This headset is mostly used when you want to be on a calm state. So this headset basically tells you when you're getting stressed, and it also tells you when you are being concentrated. And you only need four electrodes to do that. There's no need to have your 32 electrodes on your head. You can just do it easily with this Muse headset, which is also very accessible and super consumer friendly and easy to get started with. Then we have this other one. This again, this is also very consumer friendly. I'll say it's not very cheap. This is actually very expensive. It's like 1K USD. approx. That's the commercial price. And I would say it's very consumer friendly, not because of the price, but because it's very easy to get started with this headset. This headset features, I think it's one, two, three, four, five, six, seven. I think it's 8 channels or 12 channels. I can count them in a while. I actually have it with me. I'll be using it during the second stream. So hopefully I'll get to show you this headset live, and we'll be able to record some live signals as well during the second part. This one is very easy to get started to. It has its own software, so you can easily develop. It's for developers, it's very beginner friendly. There's different arrays and arrangements that you can use depending on what you want to measure. So for example, this person over here, he has it like on his backside, and then like the weird coral things are on this section of your scalp. You can also put it a bit lower, but you won't get really good quality signal. But yeah, this is another super beginner friendly. It also looks really nice. So yeah. Then we have this other one. This is called Enovio headset. I've only used this thing once, and I had to tell you it was kind of hard to get started. Their software, it's, I would say it's not beginner friendly. You definitely have to know your stuff a bit, or have someone on your side that knows what he's or she's doing, or have a YouTube tutorial get you to explain this. This looks a bit more on the research side. So if you look someone on the street that's wearing these, you'll say like, oh, like, what is this guy wearing? Compared to like these other two that look really clean, and they're really consumer friendly. But now the Enovio headset, this one's actually for more of a research grade. Why? Because it has over 32 channels in there. So yeah, that's definitely a bit harder to use. They have many arrangements. You can basically remove some of the electrodes to make it simpler, depending on the experiments that you want to build. I believe this one is, I think it's wet. I think these are wet electrodes. In exchange to these ones are dry electrodes. They're all dry electrodes. And then on this one, I believe they have their own gels that you can use. And this looks like really experimental. It looks like out of a sci-fi movie, you know? Not in our campus, but I guess there are data sets available to work on. Yeah, I never worked with like data sets to analyze things. I usually always wear them live, but I guess that they are alternatives. I think I have one for ocular movement, so you can detect like ocular movement. I can share the GitHub at the end if you remind me as well. So yeah, there's definitely some public data sets that you can use if you are not willing to expand, or you do not have this hardware available. Hi, Jocelyn. I know it looks complicated. Yeah, it kind of is. I'm not gonna lie to you. This one is a bit harder to get into. But I mean, basically, with what you're learning today during this stream, I'll say it's definitely more than enough to get you started by using one of this. And I have to admit that the content that you're seeing on this stream is usually what biomedical engineers learn in about one semester during their neurotechnology classes. So yeah, feel honored about learning this stuff. When I started learning about this, man, it was hard. I was in high school. Yeah, I was in high school. And I remember that there was no content online, and there was not ChatGPT. So I had no one to ask. Like I asked my professors or these doctors that I had access to, and sometimes they don't have availability to be answering some high school student that's just learning and asking dumb questions. So I guess they got tired of me. I don't know, for asking too many weird things. But with practice and learning enough and reading enough articles and having hands-on experience with these tools, I can say that I'm really confident that you can also learn the way that I did back then. Oh, someone shared a really nice EEG dataset. I'll also be taking a look into that. Thank you. Great. So this is the last one that I have. It's the Unicorn Hybrid Black. This one is my favorite one. mostly because I began learning with this one. It was the first BCI, well, the first EEG headset that I used. It is not very beginner friendly, but it's definitely more beginner friendly than the Enovio one. This one has, I think there's different arrangements. I think you have 8 channels on this one. Let me count them: 1, 2, 3, 4, 5, 6, 7, 8. Yep, you have 8 channels on this one. You cannot change the arrangements too much, but these are the electrodes that you can use by using the Unicorn Hybrid Black headset. It's really cool to use, actually. And it also has some cool plugins that you can use on some other softwares that are out there for building BCI interfaces. So it's a really nice one. The signal quality, it's really, really good. Because that's another thing that you should be worried about. Depending on the hardware that you're using and how good it is, it's the signal quality that you will be getting. Oh, I forgot to put another headset in there. The OpenBCI one, that's another headset. Let me type in the name in there. OpenBCI headset. That's the name of the company, but they have different hardwares in there. I believe one's called OpenBCI Ultra Cortex Cyton board. That's another headset. I would say that one is the hardest one that I've used, because that specific headset is a headset that you can build yourself from home. So it's something that you can buy the materials in your home, you can 3D print it, and you can have access to it. Wait, let me actually look at it. Let me search it online so I can show it to you all, because I think it's really worth seeing it. Ultra Cortex Mark. Let me share my screen. There we go. Okay, so the OpenBCI Ultra Cortex. So as I was telling you, this one, it looks more handmade, you know? It's 3D printed. It has Arduino cables in here, or well, jumper wires if you've done electronic circuits before. And you can basically build this in like less than, I'm doing a rough estimate, but less than 50 US dollars. The expensive thing in here is this board, which they have different types of boards depending on how many channels you want to have. So this thingy in here is the expensive thing that you're going to have. I think they also have their electronic diagrams in case that you want to do the board itself. So a really nice thing about OpenBCI is that they do open source things. So you can basically go really into depth and modify their hardware or software if you want to. I've used this one before, and the signal quality, it's not very beginner friendly. I wouldn't say it's a bad headset. It's definitely a good headset, but you need more experience to get some really good quality signals. And I'm not the person that has a really good experience using this. So hopefully I'll be learning more about this headset soon to get started. But yeah, this one is another one that's available on the market. Okay, so those are all of the headsets that I've used, and I believe they pretty much cover the majority of common headsets. If you know of another one, feel free to drop it on the chat so I can take a look. I'll definitely be interested on learning more. We have another question. I recently worked with the Ultra Cortex, and the graphic interface was a bit hard to work on. Are other headsets more beginner friendly? Oh, I definitely get you with the OpenBCI graphic interface. I would say that's a medium level of good. There are other headsets that they don't even have a graphic interface, and it's just really messy. I would say the Unicorn Hybrid Black is good, but there's not much that you can do on their graphic interface. You just can basically like visualize the signals, and that's all. So for the OpenBCI and for the Unicorn Hybrid Black and most of the commercial headsets that are available, I'll be showing you some of the software that you can use to integrate these headsets directly into that software instead of going directly to their graphic interface. So if you want to learn about like a generic software to use with all of the headsets. I'll be teaching that at the end of this stream and also for the whole time of the next stream that we will be having. Okay, so we've learned about EEG signals and some of the headsets and hardware that is available on the market for you to use. But now it's time to get into brain-computer interfaces and how they work and everything related to them. So BCI, or brain-computer interfaces, what are they? So these are basically things, it's a specific technology that allows you to communicate directly your brain into your computer or external device. So I know you've perhaps seen those videos online about people controlling things with their brain waves, like, oh, like controlling this game only using my thoughts. So that's actually possible. It's really hard, and I wouldn't say it's a thing that you can do from one day to another, but it's definitely a really good thing and a really interesting thing that you can get into. So, brain computer interface, as the picture says, it uses your brain signals to control external device. So, this is external device. It can be your computer, it can be a robot, it can be your microwave, a light bulb, it can be whatever you want. So you can control anything just by using your brain signals. So basically, no muscles needed, no speech, no buttons, no screens required. Just by thinking of the action that you want to perform, then you'll be able to execute that action on whatever device you are having. So there's three simple steps for a brain-computer interface: detecting your EEG signals, translate them into commands, and sending them to control something. So again, you can control robots, which is the most common thing, or you can control things on your computer as well, which is another common thing. Or you can also control hardware, like just turning on and off a LED light. But yeah, that was actually my first project on BCI, using the Unicorn Hybrid Black to turn on and off a LED light that I had on Arduino. The Arduino part was the simplest thing ever, but the whole software that was behind and all of the EEG signal analysis was definitely the hardest part. It took me like about 2 months to do that project, but that was just because I didn't knew anything. So I was just a newbie learning how to do stuff. So I had this super expensive headset and I had access to this lab, but I was just getting used to on how to use it. But yeah, definitely with the things that you will be learning today, it will be so much easier and faster for you to build this project that you've been wanting to build using BCIs. Okay, so hopefully the concept of BCIs is clear by now. Here is another cool diagram about how it works. So there's different steps. So you have your signal acquisition, then you have your signal processing, and then you have your actuator. So your actuator, it can be a robotic arm, it can be playing some music, it can be anything that you can imagine that you want to control with your brain, you can actually do it. So there's a lot of pre-processing going on and signal processing going on as well. I'll be getting into that very shortly. I wouldn't say it's hard, but there's definitely some things that we need to get into. For now, I just wanted to understand the concept of what a BCI is. So when you are asked or you want to learn more about this, you actually know that it's controlling something external with your brainwaves. How do you get access to different headsets to tinker with? Is it just local hackathons, makerspace, or through MLH? Okay, so glad you asked that. So usually university labs, they have at least access to one of these headsets. You can ask your university if they have access to these types of EEG headsets. There's some hackathons that provide them as well. I know there's one. It's called MIT Reality Hacks. I believe in that one. OpenBCI is sponsoring that hackathon. At least it sponsored it last year, and they borrow these. You can borrow these headsets for building your hackathon project. And then I believe there's also some other hackathons where you can use this. I think CalHacks is another one. Last year they also had these types of headsets available. You can also enter to different BCI communities, and sometimes they organize hackathons in person, and you can rent. Well, you cannot you do not need to pay, but like you can borrow those headsets for the time of the hackathon. The only thing is that sometimes these cool hackathons they go on in places like Europe or places that are like really far for people that live in America to attend to. But yeah, I'll say just look for your local hackathons and see the sponsors or ask which types of hardware will be provided. Or the easiest one, just if you are a university student or you are someone who is affiliated to a university or a research lab, you can just ask them if they have access to EEG hardware. And they should be able to provide you with a list in case that they have. But yeah, hopefully that answered your question over there. Awesome. So we covered what a BCI is, and now let's get into how to actually build one or how to process this. So the process to build a BCI, it's not simple, but I'm going to make it simple by explaining it to you on really easy terms. So there's several steps that you need to follow. So number one, there's a signal acquisition. So we already learned about that. So we already learned that we have EEG electrodes and that we have to record brain activity, right? Then after that, we also learned that there's some pre-processing. So we need to filter out noise like eye blinks or muscle movement. Because by measuring signals on your brain, you can be imagining like, okay, there's many things going on in my brain right now. How do I actually stay with the signals that I want to stay with? So the way that you do that is by doing these pre-processing. So you filter out the noise that you don't like, and then you just keep the things that you want on your signals. So what are some examples of the things that you don't like on your signals? So if I'm, for example, measuring concentration, then why would I be wanting to measure eye blinks or muscle movement or head movement or anything else related that's unrelated to concentration? So to do that, there's different filters that you can use in order to cut off the eye blinks and the muscle movement. Because when you are wearing these headsets, the signals are very sensitive. So if you blink like too much, or like you move your head, or if you clench your jaw like really hard, you'll be able to see those that effect in the signals, and that's just basically noise that's going on. And you want to filter that out so you can have the clean signal go on. Then after you have your clean signals, you want to extract the features. So you want to identify the patterns that you're going to be using for your BCI. And after you identify those patterns, then you go ahead and classify them. How? Using machine learning. So if you know about machine learning, some of the most common algorithms, we'll be getting into that as well. You'll be building your own machine learning algorithm in order to classify the signals that you want to use. So hopefully this is another cool application of where you can use machine learning, not only to build data science projects, but also to build a brain-computer interface. And the last step will be device control. So convert that into an actual real action that you can have. So it can either be control a computer cursor or a robotic arm, as we are seeing on this diagram. I believe this diagram basically summarizes most of the things. So we have signal acquisition in here, then you have the signal processing, and then you have your device control, which is either something like a hardware thing or an actuator that you have external to your brain waves. Okay, so I know these steps. I tried to summarize them as much as I could, but if you have questions, always feel free to drop them on the chat as well. Okay, so we now covered what is a BCI, how to build a BCI, some of the steps, and now there's also different types of BCIs. So I guess you didn't know that there's different types of BCIs, which is actually true. I learned that quite recently, like a few months ago. Like I've heard of these things before, but I didn't know there were actually different types of BCIs. So the most common one, which is the first one, is the motor imagery one. So for this one, how it works is that you imagine movement, your body parts, and you, by doing that, you are triggering specific rhythms to change on your brain, which are called mu waves and beta waves. So we already learned what a beta wave is, but we haven't learned what a mu rhythm is. We're going to be learning that soon. So for motor imagery, it's just basically imagining movement of your hand or your leg or your head or whatever movement that you want to imagine that's related with your body, and then you analyze the mu and beta rhythms, how they change, and that's how you identify those. You classify those movements into doing something with your BCI. That's the first one. Then we also have the P300 speller. This one is mostly used for typing with the mind. So if you want to build like a mind controlled keyboard, then you will be getting into P300 speller. And the diagram that I have over here on my right, that's a diagram of a P300 speller. So you basically see like some arrays of letters on the screen, and you see how they are changing, and how you view them is the event related potential that you will be having, which is a P300. So that's how you can basically identify each individual letter on the keyboard. And then finally, we have the SVEP, which is related to evoked potentials. So this one is just basically looking at a flickering light, and you can use that flickering light to control something. So you just will be seeing like blinking lights on your screen, and you will be using that to control your robot or to control your light bulb or whatever thing that you want to control with your BCI. And yeah, as I was mentioning, for this stream, well, this set of streams, we'll be focusing on motor imagery. So honestly, in a personal note, I've only used the P300 once, and I've used the motor imagery like 4 to 5 times. So I say enough for me to explain you some of the common techniques that can be used, but I've never used the both potential ones, which is the last one in here. So yeah, if someone has used these two before, feel free to share your experience so we can also learn from hackers. Okay, so as I was saying, we will be focusing on motor imagery. So what is motor imagery actually? It is basically when a person imagines movement a part of their body without actually moving. So how the experiment for these BCI works is that you will be having a person that's like sitting on a resting state with like their hands and palms up in a chair, as this person is doing here on this diagram. And then you will be telling the person like, okay, you need to imagine the movement of your left hand when you see a left arrow on the screen. So whenever the user sees a left arrow on the monitor or on the screen, they will be imagining the movement of their left hand. So they won't actually be moving the hand, but they will be imagining that they're moving their hand. So by making that relation with what the user is seeing on the screen compared to the imagined movement that the person is thinking of, you will be able to identify specific rhythms in the sensory motor cortex, which is on your brain. And yeah, that's how you get those analytics, and you get to pair up when the user thought of moving their left hand related to when the left arrow was going on the monitor. There's a screen in here. There's a diagram in here about how it goes. So you basically have these arrows. They can be different things. It doesn't necessarily need to be arrows. It can be whatever you want. And you sit down, you face a computer, and then you start imagining the movements once you see left arrow or right arrow, depending on what you want to imagine. This is just an example of how motor imagery works. There's more things that you can do with it. There's more movements that you can replicate. So it's not only with your hands, it can also be with your feet. I think it can also be with your tongue, or by imagining like jumping jacks, the one where you open and close your arms. You can also imagine those, and you can associate that with with a, how do I call this, with it's not like it's not a diagram. It's well, the arrow that's going on in the stream, in the screening there. You want to relate those movements with what you were thinking of. I know this concept might sound weird, like why would I imagine something and how would I be able to even measure that? So it's actually possible to measure when you think of something or when you are imagining that you are moving a body part. It's very obvious to measure that. Of course, you need really good quality EEG signals, and you want to focus and filter out whatever is not into these frequencies. So you can filter out everything that's not from 8 to 30 hertz. So you can focus on what you want to filter out. Okay, so now let's get into some example projects so we can actually get started with this. So as I was mentioning, as we are focusing on motor imagery, some of the things that you can do, cursor control. So you can basically control something in your computer. You can also build like a robotic arm control, which is a project that I built before. Hopefully, I'll be able to find my research paper so I can show it to you and see some of the videos that I had in there. And you can also use it for rehabilitation. So, like for patients that do not have like movement on their hands and they just have brain activity. So these BCIs, they're not just for being cool and us being able to control things with our minds. It is actually also helpful for people that do not have their movements available. So some of the other prosthetics out there on the market, they use your muscular movements in order to create the movement of the hand or the prosthetic that you're using. But what happens if someone does not have motor movement, or you cannot measure those things from their muscular activity? So you cannot actually use these types of prosthetics that are out there. So you will need to use their brain activity in order to control the prosthetic of their choice. Okay, so before going into downloading this software, I'll be seeing if I can find that research paper for you all. Research. Let me see. So I actually worked for this project for over, found it. I worked for this project like for over 1 year and a half. So it was a while, I have to admit that. But now I'm working on different projects related to BCI. Like for my most recent hackathon, we built a BCI as well. And then right now I'm part of a research group for my university that we're building another BCI. So yeah, there's plenty of things going on. So once you start building your first one, then it's easier to start exploring different areas as well. Okay, so let me share a new window. Hold on. Okay, so this one is another one that I have in here. I'm not going to be reading like the whole thing because it's going to be like super boring for you. But these are kind of the things that I covered on my research paper. So I actually used a software called OpenVibe, which is the one that I'm going to be teaching you today to use. And I use the Unicorn Hybrid Black headset, which is the one that we already use. And then I use motor imagery in order to detect the signals that I wanted to produce an output on a 3D printed hand prosthesis and the design of everything that's into that. Let me see if I have an abstract in here. Okay, there's actually an abstract. I'm not going to read that. I just want to go into the picture so you can see how it looks like. Okay, so In this screen, I'm basically summarizing in this diagram like the whole experiment. It's a lot, I know. This is a headset that I use. Here are the electrodes. I mostly focus on using the C3 and C4 electrodes, which are on the central area. So basically, this section of your scalp. So you have C3 and C4 over here. And I use those two specific electrodes because they are related to movement of your hands. You'll see why I chose those two specific ones. And then here's a picture of my subject test. This thing that I'm using, it's not harmful. It's just a saline solution that I use in order to make the conduction with my scalp better. And then I could see the quality of my signals in there. If you're seeing, these signals are not very high quality ones, because if I can see the arrangement in here, I only have one in green and the other ones are still in yellow, so it's not really good quality. So hopefully I had to wait a bit more in order to start seeing the signals in there. And if you see in here, you can actually filter your scale in volts and then your bandpass filter. So this is a filter depending on which frequencies you only want to use and the ones that you just want to cut off. This software, it is only for visualizing the signals using the Unicorn recorder. You cannot do anything from there. That's why I used OpenVibe. And then let me see if I have more pictures. Yep. So this is the other picture about motor imagery. So I basically had my user sat down in front of a computer screen and they were seeing these coordinate in here, and then random arrows from left to right appeared. And for example, let me see. The subject test had been trained with the purpose of training the brain for you to imagine the movements of the hands according to the position of the arrow on screen. So we're seeing the arrangement in here. So if the person saw left, right in here, then she closed her right hand. So I basically did one with the actual movement, and then I did another recording session with just imagining movement. So no closing and opening, just imagining that you are closing or opening your hand. So this was the arrangement of the person sitting down. And then let me see. And yeah, these are just basically like the results of my machine learning algorithms. It looks super bad in here. I need to change that. But yeah, and then let me see if I have, this is the prosthesis of the hand. This is how it looks like, the electronics in there, my electrical board, how I designed the forearm in order to have everything in there. And then this is like the final product. But yeah, and these are more results in here. Final product as well. And yeah, that's all. I think I have some appendixes in there of the signals. So this is just a very simple example of how unfiltered signals looks like. We'll actually be seeing these as well. The 1020 arrangement in here, the delta waves, theta waves, and alpha, those that we already learned. We'll be learning about this in a while. This was so crazy. But yeah, I'm not going to scroll more because maybe I will scare you, definitely. So I'm just going to remove this, go back to our presentation. We have a question in here. To what extent do you find diving into heavy math to start diving in the field? So I'm definitely not a math person. I am really bad at math. I believe I never needed math to do all of these things. I think for the machine learning section, you definitely want to know how the algorithms work. But I've never encountered a step by doing all these experiments where I had to be really proficient at math. I'll just say it's more of having a better understanding about frequencies and filters. I think filters is the most important thing, which is kind of related to math. But just by knowing how they work, usually softwares, they do that automatically for you. But yeah, it's not very hard. It's definitely not very hard. Just by knowing the concepts, you're way ahead from other people. Okay, so now let's dive into downloading OpenVibe. So let me move on over here. Okay, so let me share this link with you on the chat so you can also download this. Oh, too bad. I actually closed this. Slides. Just give me a second so I can pull up the slides and send you that link. Or I can also just look it up directly. I think that's better. Yep. OpenVibe. So I think OpenVibe, I don't know if this has support for Mac users. I think it does, but like an old version. Okay, so I sent the link in there. Let me open the software over here and I'll give you some minutes for you to download this. Let me just remove this. Hold on, let me share my other screen so you can see exactly what I'm doing and we don't get lost. There we go. So hopefully when you click on that link, you'll be seeing this page. I know it doesn't look very high quality. It looks like it was made in the 2000s, perhaps. Uh, it was made by WordPress, okay? It's not our best high quality page in here. But this is definitely one of my favorite softwares to use for BCI support. So cool, but no Mac support. I think you can have Mac support from older versions because my how do I my the doctor that I was working with, she had a Mac computer, and I believe she ran this using older versions. I'm not sure. Let's see, downloads. Stable Windows, source code, later source code, offline documentation. Oh, no, it's actually only for older versions, Windows installer. During our experiments, oh, there's also some data sets for the hacker that was asking about data sets. There's some data sets that you can use in here. Well, you have to put in your personal info, but yeah, you should be able to access them. So yeah, sadly, there's no Mac support. But hey, if you're into robotics and BCIs, you must get Linux then on your computer. Right now, I'm doing the whole stream on Windows because it's a pain using Linux microphone and camera. So yeah, if you're into these types of things, I recommend you to start using Linux because you won't be having issues with most of the hardware and software things. Usually for computer science, having a Mac is perfect. But then when you get into hardware, there's these super weird softwares that are being used, and some of them are old and some of them don't have support for some of the common operative systems. So they run better when they are run by Linux operative systems. But yeah, if you don't want to download that, you can always install a virtual machine and just run it in there, and that will be definitely better. Okay, so and no worries, will not be doing super complex things in here, so it will be recorded in case you want to see it again. Okay, so I'll just give you like 5 minutes in order to install this because I know for some folks it can take a while, and then I'll be explaining you the different things that you will be downloading on your screen. So, okay. There are some package contents that will be downloaded in there, such as the acquisition server and the scenario designer, which are the most important ones for us. I'll be giving a short break of 5 minutes, let's say, and then we'll be back after you all downloaded this software. Okay, we are back. Awesome. So hopefully, most people on the stream were able to download the OpenVibe software. This actually looks like a super sketchy page, but I promise you, it's a really good piece of software for using, and it will be very helpful. And you'll see in a while why you can integrate it with many of the commercial headsets that are out there. So this is the first software that I started to use when I first started into BCI and EEG analysis. And we can actually discover some of the things that are in here. OpenBuy is a software platform dedicated to signing, testing, and using brain-computer interfaces. So that's super nice. And here are some examples. What is a brain-computer interfaces? Discover OpenBuy in 4 minutes, and then some like overviews and so on. And if you see these videos look kind of old, because this was actually from 2015, and these videos are for 2013. So I'm pretty sure there's new content, but I guess OpenVibe hasn't updated themselves. Oh, there's even like some contact info in here. It will be really nice to meet them. That will be really, really cool. Oh, and I remember when I was having some issues with my project, I remember I entered to the OpenVibe forum. I think you need like credentials or something, and it was really hard those days when there was no information online and there was no chat GPT to guide you, just you and your computer figuring out the box that you had. Great, so let's get started with using this tool. I'm going to start sharing my whole screen now so you can see my desktop and everything. Let me just close this and stop screen, start new screen. Let's see. Great. So now you're seeing my complete screen. And from here, when you download something from the BCI, if you downloaded it correctly, you can just search OpenVibe and you'll be seeing two things in here. So you'll be seeing the OpenVibe designer, and then you'll be seeing the OpenVibe acquisition server. So the acquisition server, as its name, acquisition, it's to acquire the signals. So we'll be acquiring those signals from there. So it's basically where you will pair your headset or you will be generating the signals in there. And then the designer is where you actually build your BCI apps. So we are going to go ahead and click on the acquisition server first. And it will put you like a weird script in here. Just ignore that. And then you will be seeing these in here, which is the acquisition server. So in here on the driver, if you're familiar with electronics, the driver is just basically the hardware that you're using to control whatever thing. In this case, it's for measuring our EEG signals. So the cool thing that I remember some hacker asking about an alternative to the OpenBCI graphic user interface. So you can actually connect your OpenBCI headset from here. So you just select OpenBCI and then you are good to go. You have more in here. You also have, I believe, you also have the Neurosky, the Shimmer. I think there's also the Unicorn Hybrid Black. It's also in here somewhere because I've used it before. Unicorn. Lab streaming layer as well. I'm not seeing it. That's weird. But yeah, you can use some of the most common headsets in there. For our tutorial, as I don't have any of these headsets with me right now, I'll be using the generic oscillator, which is kind of like a fake signal that you can run just to make tests and to make sure that everything's working correctly. So it's like an artificial signal from your computer. And then you can actually customize your driver properties. So if you want more channels, depending on how many channels your headset has. So for example, I'm going to write 8 channels. Your sampling frequency. If you want to specify the gender or the age of the person, or even change the channel names. So for example, in here, I can assign specific channels to my numbers in here. So for example, let's say that I want to have a C3 and I want to have C4 as well. And then let's see, I want to have, let's do frontals, F4 and F2. I'm just placing them random. You don't need to do this. It's just to show you that you can basically pair the lecture names that you want with the channels that you want. So let's say that your headset supports 8 channels, and you know that the electrode number 1, it's F8, for example. So then you go ahead and you pair F8 with 1. So just go ahead and do that. Because usually your headset, when you use it on OpenVibe, it doesn't know which channel it is. So you need to specify it directly from here. So just by this, you should be specifying all of the channels in there. And by that way, you are making sure that your headset is reading the actual, from the actual channel. Because I had an issue before where I was not getting the result that I expected to, and that was just because I didn't configure this at the beginning when pairing up my Unicorn Hybrid Black. So yeah, that was a sad thing to realize. Then you click on apply and apply. Great. So after having that, you can also click on preferences. There's some other things that you can configure from there. On the next stream, we'll be learning about LSL and markers. So I'm not going to explain this right now, but we will be seeing it on the next one. Okay, and then you just click on connect and play. There we go. So hopefully on your console, you should be seeing that you are now acquiring signals in here. So started acquisition and now acquiring. So now your generic oscillator is working. So how do we see those signals? So we're going to go ahead again and search. And now we're going to search for the designer. So OpenVibe designer. So let's open that one. It also has another console thing going on in here. And then it actually loads these things. So let me place this one over here. Great. So I have some scenarios in here. I'm just going to go ahead and create a new one, just a blank one. And the cool thing about OpenVibe is that you do not require any coding. All of the things that you have in here are using blocks. So it's blocks, and you can click on them and you can basically configure them inside. And you just basically grab this and start connecting them to the blocks. Of course, you need to know what you are actually connecting, but hey, it's easier than having some Python code in there that you might not be understanding so well. And yeah, this is very cool because you can learn how the blocks work, and those blocks are actually concepts in the BCI world that you can use. So you can see them in a more intuitive manner, and it's easier for you to use them. So let's get started by doing our first visualization of our signal. So we're going to go ahead and here on acquisition and network, and we're going to click on acquisition client. So we're just going to drop it. There we go. So the acquisition client, it relates to acquisition, right? So what it is our acquisition server. So everything that we are reading from the acquisition server will be automatically sent over here. So that's why we have a variable in here, acquisition server host name. And then we have a port where we are sending all of our data in there. You can also load files, and you can read those files as well from here. And now to visualize the signal that we're getting, we're going to type in visualization. Nope. I think it's signal display. There we go. It's called signal display. So signal display over here, and I'm just going to connect the signal stream over here and the stimulations. There we go. Whoop. This is very sensitive. There we go. And on my signal display in here, you can also configure this. So you can have different offsets in there, and you can also save that data into files so you can later analyze them. So I'm going to save this thing, and I'm just going to call it test stream. Click on save. There we go. And then I'm just going to go ahead and play it. And if you're seeing, these are just generic signals that are going on in there. Nothing special. I actually have the channels in there. And it's just a generic stream reader. So it's like if I was having my headset right now, but I don't actually have them. So yeah. So for the hacker that was sending that cool data set of EEG signals, you can actually plug those into OpenVibe so you can play around with them as well. Okay, so let me stop this over here. Awesome. So I guess that will be all for the first part of the stream, because I wanted people to have a small break before the second part, because the second part will start in 30 minutes and I don't want us to be connected the whole time. So yeah, for the next stream, and yeah, hopefully you were all able to run this. I'm also going to be explaining it a bit further on the next stream. We'll be applying some filters in here as well so we can see the signal a bit more clear. And for the next stream, I'll be explaining some of the most common machine learning techniques, some of the techniques for features extraction, and then I'll be also using the Neurosity Count headset. So the one that I showed, I believe, at the beginning, I'm going to be using that one live. So definitely stay tuned for the second part, because I'll be doing my own live demo, and hopefully we'll be able to visualize those signals live, and we can also play around with them, and I can show you what the SDK looks like and another software that you can use for signal visualization as well. Okay, so great. I guess I'll be seeing you. I'll be seeing you in about 30 minutes. I'll also be sending the announcement on the Discord. And yeah, take care and see you in a while. Bye, everyone.